Hi guys, welcome back to the channel. So in today's video we'll be discussing some concepts of DHCP option sets and Route 53 resolvers using private hosted zones to allow internal DNS communication to instances. So for example in here I'm using ping target, and I'm getting a result of that IP address which is of the target. I can also then use the target.lab.internal, which will then use the private hosted zone to then resolve this IP address as well. So within AWS, I'll go through the DHCP option sets we use to set up the lab.internal, the hosted zone as well, where we add the A records to resolve Kali to its IP address, and same as target, and then also discuss the deployment of EC2 instances used for the demo purposes. So before we start deploying infrastructure, let me walk you through what we're actually building. So on the left, we have the DHCP option set. When each instance boots, it receives two things from it: the DNS server to use, which is Amazon provided DNS, and the search domain lab.internal. That search domain gets written straight into the resolve.conf, which is here. Inside the VPC, Amazon provided DNS resolves to the Route 53 resolver sitting at 10.0.0.2. That's always VPC base address plus 2. So if your subnet is 11.0.0, there'll be .2 at the end as well. The resolver then checks whether there's a Route 53 private hosted zone for lab.internal associated with this VPC. As there is, it then contains two A records, kali.lab.internal and then also target.lab.internal, each pointing to the private IP of the respective instances. So when our Kali box runs ping target, step 1, the search domain appends.lab.internal, making it target.lab.internal. Step 2, that query hits the resolver. Step 3, the resolver finds the matching A record in the private hosted zone and returns the private IP. Step 4, Kali communicates directly with the target over the private network. No public internet involved. On the target is running an Apache server, so when we curl target and we get a HTTP response back. And to be clear, the DHCP option set's job is just to search the domain shortcut. The Route 53 private hosted zone is doing the actual resolution. If you queried the full name target.lab.internal, it would work even without the DHCP option set. So the DHCP option set just allows you to use target or Kali to communicate to the instances. So as with all my videos, I'll attach the infrastructure as code, the Terraform I use to deploy all this in my GitHub in the description. So yeah, let's just get straight into it. So to start, we just run a Terraform apply from within the repository. We can now see what it's going to try to deploy. So if I open this up a little bit, we can see subnets. We're deploying the private hosted zone, the Route 53. I'm deploying this all in a VPC as well to keep it separate. So yeah, we've got an instance called Kali, and then we have an instance called target. Creating some key pairs so we can connect to the instance, some Route 53 records for target and Kali, private hosted zone, route tables, security groups, VPCs, DHCP option set association. So I'll also show that in the console as well. So if we now select yes, this is now going to start the deployment of this VPC. There's two instances that we're going to use for the demo today. If I navigate over to the console whilst that's deploying, I'm going to type in the DHCP option set. So DHCP option sets. So here we can see the DHCP option set has been deployed. So this is the default one for my other VPC, and then this is the one we've just deployed. So we have domain name lab.internal, and then we've got the Amazon provided DNS, which always goes then to the Route 53 private hosted zone. So if I now open this one up, I've got two, but that's because I've already had one in the account. The main one here we can see is this private one, which is now managed by Terraform, lab.internal. And here we can see we have two records here. Now, if I was to refresh this, we should see some A records be populated here with the Kali and the target. If I just navigate back to see if it's still deploying. So AWS Root 53 zone is still being created. I think they're just creating the records now based on that. Perfect. So we can see now we have two A records added. So we have the kali.lab.internal, which is at 10.0.1.170, and then the target, which is at 10.0.1.39. If I now go to EC2 as well, we should be able to see our two EC2s deployed. There we go. So Kali in the target. And now I'm going to go back here. So Terraform's run is completed. I can now run these commands here to get onto the instances. So an important thing I forgot to mention at the start was to with the Terraform TFRs file is to ensure you add your own public IP address to this allowed SSH seeder. What that will allow it to do is when the security groups get created, it will allow you to communicate over public IP to that instance. So if I copy this command here, sh-i, that's using the key. It's also created as part of the infrastructure code. And here we are inside the Kali Linux instance now. So if I was to cat etc resolve.conf, I can see the domain name lab.internal and the search for lab.internal added as well as the VPC DHCP option provided Root 53 resolver as well. So whenever you search something, it will try the lab.internal. If it doesn't match that, it will then resolve to this this resolver. Then you can communicate to other DNS records on the network as well. Perfect. So if I was to now run a ping command against the lab target, so it's called target.lab.internal. Here we can see we actually get a response from the target using its domain name of target.lab.internal. And I think as well we've also got a web server running on there. So I can also use that domain name to resolve that as well. Perfect. So that shows the communication between the two instances using the DNS of the Root 53 resolver and the ones we've added to the root table as well within the Root 53. So where the DHCP option set comes in is where now we can communicate to the instances just via its domain name of just target. So the lab.internal is not required and we can just communicate via this. That in this scenario is the only reason for the DHCP option set. Some other examples of where you might want to use your own custom DNS server where you resolve your own, essentially doing what the Root 53 internal host zone does. You could have your own DNS server doing this, and then to do that you can set, instead of lab.internal, you can set this to be your own DNS server that when your instances go out to talk to something, you can have that be the first server it goes to do some DNS resolution. Some scenarios where you might want this is your own custom NTP server. You might have an Active Directory domain where you want to resolve internal domain names, or you have multiple instances with the same domain name, but you want to make sure they're getting routed to the correct one. That's specifically common in some lab environments, but yeah, it's quite niche. Perfect. So to clean up now, I'm just going to run Terraform destroy. So if I exit out of Kali, and now just run a Terraform destroy. This should now clean up our environment and not incur any costs. Just a little bit on the cost. So to have a private hosted zone in AWS, it costs 50 cents a month. And then I believe it's something like 0.40 cents per million requests or something. So for your own internal lab environment, it's very, very cheap to run. A lot cheaper than hosting your own DNS container to do this resolution as well. So I think that ends the video, so thank you all for watching. Any comments or questions, please leave them in the description, and I will see you all in the next one. Thank you.